this lesson, we're going to learn about some special types of segments that are in triangles. So the first segment that we're going to learn about is called a mid-segment. So if you think about this word, you have heard of a midpoint. So a midpoint is a point in the middle. So this has to be a point in the middle of a segment, where a mid-segment has to be a segment. So it's a segment that connects to two midpoints. So that's why you see the similarities in the words. Midpoint, they both have the mid part of it, so that's indicating the middle. So a segment that connects to two midpoints. So what that looks like, if you have a triangle, you would have a midpoint on one side, and then if you have a midpoint on the other side of the triangle, notice that these aren't necessarily the same distance as the other sides, but they're both midpoints. So if you have two midpoints, this segment right here is called the mid-segment. So this segment is our mid-segment because it's connecting to two midpoints. So there's two other big ideas or properties or theorems that the mid-segment has, and one of them is it's always half the length of the side opposite it. So this segment, if this were 5, down here would have to be 10. So the mid-segment is half the length of the opposite side. And then the other big idea is that the mid-segment is always going to be parallel to that opposite side. So the mid-segment is parallel to the opposite side. So using those properties and using the definition of a mid-segment, let's go ahead and answer some questions. So the first thing here is it tells us that we have some midpoints. So that indicates that we have mid-segments. So if L, N, and M are all midpoints, that means these two segments have to be equal because a midpoint divides a segment into two equal parts. N is the midpoint of BC, so that means these two sections are equal. And then M is the midpoint of AC, meaning these three segments are equal because M is a midpoint. So then that also means that LN is a mid-segment because it connects to two midpoints. MN is a mid-segment because it connects to two midpoints. And LM is a mid-segment because it connects to two midpoints. So if we look at this, it says LM is parallel to blank. Well, if LM is a mid-segment, it's always going to be parallel to the side opposite it. So the side opposite it is going to be BC. If we look at AB, it says AB is parallel to which side? Well, AB is going to be parallel to the mid-segment. So the mid-segment that's opposite side AB is going to be MN. The next pieces here are dealing with lengths. So if it says the whole thing, so AC is 20, find LN. Well, AC, if that whole thing's 20, the mid-segment is LN, the mid-segment that's across from AC, that has to be half of the 20. So that has to be 10. Because that's one of our properties for mid-segments. If MN is 7, AB has to be twice that because the mid-segment is always half of the opposite side. So this has to be 14. NC is 9. So if NC is 9, it's asking for the length of LN. So here's the way that you can think of this. Well, one thing you could do is you could say because this is 9, this has to be 9 since N is the midpoint, meaning this entire side has to be 18. And then the mid-segment is half of that, so that's going to be 9. That's one way. The other way is maybe you notice that all three of these parts are always going to be equal. So the part of the segment opposite the mid-segment will always have the same length as the mid-segment because this is half of the whole segment, and so is the mid-segment. So you see all the same numbers there. So that also is an option to think of it that way. And then this next question is a common question that I've seen come up a lot, where you have a picture like this with some mid-segments. It tells you that you have midpoints. You have to be told that you have midpoints in order to say that these are mid-segments. So we can say that all these are mid-segments. I know that I have all these congruent parts because it told me that all G, F, and E were all midpoints. And then it gives me some numbers. So it says CD, so this entire thing is 14. GF is 8. And GC is 5. We are trying to find the perimeter of triangle BCD. So BCD is the big triangle. We want to find the perimeter of that. So that means we have to be able to add up all the sides. So find some missing information here. If this is 5, well, this piece right here is going to be 5 because G is a midpoint. So that means the whole thing is 10. And then this mid-segment is 8, so that means across from it has to be 16. So then the perimeter of the big triangle, BCD, is going to be add up those sides. So 10 plus 14 plus 16. So when we add those up, we will get 40. So then that means to find the perimeter of the smaller triangle, there's really 2 ways that you could do that. You could say, you could find each of those side lengths first. So I already have the 8. I can go across from the 10, the mid segment would have to be 5. And then across from the 14, the mid segment would have to be 7. So I could just add those up. So it could be 7 plus 5 plus 8, which ends up giving you 20. Or the other option for that is to just take half of the big triangle, because if all the sides are half and the perimeter just means add up all the sides, well, then that means that the perimeter will also be half. So I could just take the perimeter of triangle BCD and divide that by 2. So 40 divided by 2, and I get 20. So either way, you get the 20. So it's really your call on how you want to do that. So if we go to the next page, there's some other vocab that we need to talk about dealing with segments and triangles. So I kind of want to sketch a picture for each of these and just kind of give you a little description. You've heard of a lot of these things before. But if we look at an angle bisector, this is bisecting an angle. So you've heard of this. So it's cutting, let me not write bisect, let me write cuts an angle in half. So cuts an angle in half. So you've heard of this. But in terms of in a triangle, what is it connecting to? So if you imagine you have your triangle, an angle bisector is always going to go from the vertex to the opposite side so that the angle is being split into 2 equal parts. So connects from vertex to opposite side. So that's where it's located. Perpendicular bisector you've also heard of, but you haven't necessarily seen it in a triangle. So a perpendicular bisector has to form right angles. So forms right angles and cuts side into 2 congruent segments, or in half. And for this, how it's going to connect, so if you have a triangle here, a perpendicular bisector does not have to pass through the vertex of one of the vertices of the triangle. What it does have to do is it has to go through the midpoint. So what you do is you identify the midpoint, and so that point right there is the midpoint, and then your perpendicular line has to pass through that midpoint and make sure that it's perpendicular to that side. So it has to be perpendicular to side passing through midpoint. And it may or may not cross through vertex. So that's what's kind of unique about that. And it can be a line, it can be a segment, it can be a ray. Doesn't make a difference. When an angle bisector, that can be a segment, it could also be a ray. It's not going to be a line though. Typically it could be, I guess, but it typically isn't, because usually it's starting at the vertex and it has an endpoint and it connects and passes through it. The next one's altitude. So you've heard of altitude in terms of it's a height. So altitude of a triangle. So an altitude of a triangle is going to be the height of a triangle. So it has to connect to the vertex and it has to be perpendicular to the opposite side. So it's the height of a triangle and it has to go from the vertex and perpendicular to opposite side. And remember, for an altitude, sometimes you're going to have a situation where the altitude might be on the outside. So like in an obtuse triangle, the altitude's on the outside of the triangle. So just keep in mind, if it's a right triangle, then the altitude is actually one of the sides. So just, it has to always go from the vertex and be perpendicular to the other side, no matter if it's located inside, outside on the triangle, it has to always be perpendicular to the other side. And then median, a median of a triangle starts with an M, so it connects to the midpoint. So you go from a vertex and you have to connect to the midpoint of the opposite side. So it doesn't matter if the segment's slanted or perpendicular or not, it has to connect from the vertex to the opposite side passing through the midpoint. So it's a segment that connects to the midpoint. From vertex to midpoint. So a perpendicular bisector is similar that it connects to a midpoint, but a perpendicular bisector has to be perpendicular, so it has to form right angles, which is why it doesn't have to pass through the vertex. A median has to connect to the midpoint, and since it has to connect to the vertex, it might not be perpendicular. So that's kind of the difference between those. They both connect to midpoints, but one has to be perpendicular and one does not. So using these segments, now we're going to look at how can we make conclusions. So it tells us that we have an altitude, so CD is an altitude. So if CD is an altitude, that means there's right angles on both sides because altitudes go from the vertex and they're perpendicular to the opposite sides. It says that CE is a bisector of angle ACB. So angle ACB is being bisected by CE. So that means I have two congruent angles. These angles in green here are congruent. And then I also have a median. It tells me that CF is the median, which means that this right here is a midpoint because medians connect from the vertex to the midpoint. So that means these two parts have to be equal. So if we look at what it's asking us to do, it says state two congruent angles. So my two congruent angles are the angles in green because I had the angle bisector. So angle ACB is congruent to angle BCE. And that's because of the angle bisector. The two congruent line segments are from the median. So that's going to be AF is congruent to BF because remember a median connects to the midpoint, so it divides the segment into two equal parts. And then the last one is to get the perpendicular. Well, the segments that are going to be perpendicular are going to be the ones that were formed by the altitude. So that would mean AE. So if I look at this, AE and CD is perpendicular to CD. And for the bottom one, you could really say CD is perpendicular to AD. You could say CD is perpendicular to AE, AF, AB, whatever letters you want to use for the bottom. But the main thing is CD is the one that's perpendicular to this bottom segment. and that's because of the altitude forming perpendicular lines. So I didn't write out all my reasons here, but I tried to color code it so you can see kind of how I made my conclusions. So go ahead and using this vocab, complete the check your understanding problems.